Hello class, welcome to the next video or next lecture. So yesterday, some of you had some emails and some questions for me, so I wanted to address it. Firstly, tomorrow is not going to be a video lecture. Tomorrow you're going to have the opportunity to make up a standard. This is how you're going to do it. Okay, what you're going to do, and if you want to, you could work with people, but you have to create your own video. But what you're going to do is I'm going to give you some time in class. If you want to make up a standard, pick 3 problems, make a video, and upload it to the Dropbox of you teaching a standard. So say you want to make up the disk, the disk standard. Come up with 3 problems: a level 1 disk problem, a level 2 disk problem, level 3 disk problem. You have your old quizzes, there's problem sets in the Dropbox, whatever you want to do, but there's the only way that I can verify. Again, I know some of you hate making the videos, but there's the only way I can verify that you actually understand the material. So tomorrow in class, no lecture, there's no nothing. The only thing there is for you to make up a quiz. So if you're really smart about it, you can take some time tonight, find some questions, find the standards you want to make up. And tomorrow in class, all you're doing is making videos on the standards that you want to make up. You're also going to be getting a fairly big packet on math over a break. There's a short section on series that we're going to teach over break. So you're going to have basically a 10-minute video every day so that you know the topics for the AP exam. So I don't want to make you work. This is for your benefit. I'm not gaining anything by working over vacation and making these videos for you, but I think you guys deserve it. I think you guys need it. And I think that you'll appreciate it if you do very well and then get to skip the class in college. So that's what's on top for tomorrow and for next week. Today, a very short lecture. Your packet's going to have basically 2 lectures. I'm only going to go through half of it. It's called L'Hôpital's rule. It looks like L hospital, but it's L'Hôpital. It's actually a very simple process. I know yesterday in sequences, some of you, which reminds me, some of you haven't turned it in yet. If I look it up real quick, I'll tell you what I see in the Dropbox. So if I pull this up real quick and I let it load and let it load, I'll show you basically what I see as a teacher. I can show you and anybody can pull up the Dropbox and see what I see. But long story short, I look into the Dropbox. Unit 8, practice. So I don't know if it's people put it somewhere else or haven't uploaded it yet. I know some people emailed me they didn't finish, but I have Carlos, Carrie, Javier, Jessica, Leo, Rex, and Yoli, and then there's a whole bunch of people that have no idea where they're at. So somehow by today, get it in the Dropbox so I can verify that you understand about sequences. Okay, but today we're going to study L'Hôpital's rule. So L'Hôpital's rule is actually developed by Bernoulli, but L'Hôpital paid Bernoulli for private lessons, then published the calculus book based on the lessons he learned from Bernoulli. So even though it's not L'Hôpital who made up this stuff, they call it L'Hôpital's rule. Okay. So just some quick history about L'Hôpital's rule. So say for example, this is where L'Hôpital's rule comes into play. So say for example, a long time ago, we did limits, first month of school, and I said hey, take the limit of x squared minus 4 over x minus 2. This is what we did. We plugged in 2, and you got 0 over 0. And you're hey, what do I do? Remember, 0 over 0 is indeterminate. It doesn't mean 0. It doesn't mean infinity. It means it's not determined. So what we did at the beginning of the year, if you remember, we factored x squared minus 4 into x plus 2x minus 2. We were hey, x minus 2's are on the top and the bottom. They can cancel. So this whole thing actually means just x plus 2. And then when we plugged in 2, we get 4. Okay, so that's what we did in the beginning. L'Hôpital's rule, if you remember, or L'Hôpital's rule, what it says is that, well, what that means is x squared minus or x minus 2. That's saying that the numerator, and my pictures don't show up on here. I think they show up on your packets. Is that the ratio between this function and this function, or I'm looking at the ratio between these 2 functions at x equals 2. Okay. So as x gets closer and closer to 2, this ratio of f and g gets closer and closer to 4. Okay, or the distance between the 2 functions is 4. Okay. So for us, what L'Hopital's rule says, and I think y'all will like L'Hopital's rule. I think a lot of you will find it very simple, and a lot of you will say, like, why didn't we learn this at the beginning? And then I answer, I didn't invent calculus. L'Hopital's rule says that if you get a limit problem, and it's indeterminate, which means like 0 over 0, or infinity over infinity, or something, you can take the derivative of the top one, you can take the derivative of the bottom one, and you'll get the answer also. So remember that same problem we just did, x squared minus 4 over x minus 2? Instead of doing factoring and cancel, what I can do is I can take the derivative of the top, so that derivative x squared minus 4 is 2x. The derivative of x minus 2 is 1. So you see how this 2x over 1 is the derivative of that original problem? And now try plugging in a 2. And when I plug in 2, I get 4 over 1, or 4. Like, wow, that's so much easier. I don't even have to factor. That's L'Hopital's rule. If you get a problem where it's indeterminate, take the derivative of the top and the bottom, and try plugging in again. Okay. So here's a proof of why that works. I wouldn't worry about it. Just believe me, it works. Okay. So here's an example. 1 minus cosine x over x plus x plus 2. If I plugged in 0, I'll get cosine of 0, which is 1. 1 minus 1 is 0. On the bottom, I'll get 0 plus 0, which is 0. I get 0 over 0. I'm stuck. The problem with this type of problem is that I can't factor anything. Like, nothing can cancel top and bottom. This is a type of problem where I can only use L'Hopital's rule. Here, the derivative of 1 minus cosine x, you know the derivative of 1 is 0, and the derivative of negative cosine is sine. Derivative of x plus x squared is, derivative of x is 1, and derivative of x squared is 2x. Now, when I plug in 0, sine of 0 is 0, and 1 plus 0 is 1. You get 0 over 1, or 0. And I get an answer. So what I'm saying is that L'Hopital's rule, once you finally get an answer, you stop. That's what the answer is. If somebody, not that anybody would, but if you kept on going, you'd get the answer as half, which is wrong, wrong, wrong. I'm saying once you get an answer, L'Hopital's rule says you stop. Okay, so that's pretty cool. All you have to do is take the derivative of top and bottom. Okay, so L'Hopital's rule, though, if you form and you get 0 over 0, take the derivative again until you can get it. So here's an example. Again, this is a pain in the butt to do, but I'm just gonna. It's written out for you so you can see it. So if I plug in 0 over here, I get 0 over 0. You're like, man, that doesn't work. So in this part, I use the chain rule. I take the derivative, I rewrite it, still get 0 over 0. Okay. Here on the bottom, they do it again, but once they do the derivative, they notice that you actually get an answer this time. You'll get negative 1/8. Okay. So you have to keep using L'Hopital's rule until you get an answer. Okay. So it's not only just 0 over 0. Again, infinity over infinity, or infinity times 0, infinity minus infinity, 1 to infinity, 0 over 0, or infinity to 0. These are all the indeterminate forms where you're allowed to use L'Hopital's rule. Okay. So for example, this one is limit as x goes to infinity. Here, obviously if I plug in infinity, I get infinity. 1 over infinity, if you remember, is 0. And sine of 0 is 0. So this is an indeterminate form. Infinity times 0 does not work. Okay. This one, you may notice if I plug in infinity here, I get 0 over 0. So anyway, long story short, I'm not going to go through this whole thing, but when you're stuck in things like this, you could rewrite it so you get a fraction, and you could take the derivative of the top and derivative of the bottom and keep on going until you get an answer. Here's another version. This one is infinity minus infinity. Like, what is infinity minus infinity? I don't know. So what you can do is you can find a common denominator, subtract it, and then you have your own fraction. Okay, so this one, they did x minus 1 top and bottom, ln top and bottom, and then they found, since they have a common denominator, they subtracted across. They get 0 over 0. They take L'Hopital's rule, they take the derivative top and bottom, still get 0 over 0. Okay. Then they move on, take the derivative one more time, and they actually get an answer 1 over 2. Okay. So that's L'Hopital's rule. What I'll have you do, and this is just saying the same thing for different forms. What I'll have you do is I'll have you practice again in class. I'll post the next part in the worksheet, the next worksheet up where it says problem sets in the Dropbox. I'll have you try some of these L'Hopital's rule. Again, it's very simple. In case you missed it, all you have to do, if you get 0 over 0 for a limit problem, take the derivative of the top one, take the derivative of the bottom one, and then try plugging in that limit again until you get an answer. Okay. So you could read through, I gave you a copy of the book. You could read through if you don't understand like some more examples. But I mean, that's basically it. Try to get it into one fraction where you take a derivative over and over and over again. Okay, so that's L'Hopital's rule. So that's the last lecture for the week. Remember, tomorrow in class, all you're doing is making videos, making up standards. Don't say like, you didn't have enough time, or you're struggling. You have plenty of time tomorrow to just work on making up a standard. So if I don't see you, well, I know I won't see you tomorrow, but take care. And again, I'll see you over break using like these lectures over and over again. So take those packets home. If you don't get it today, maybe you'll get it tomorrow. I mean, I know they're thick packets, but we're going to go over series over Easter vacation. So that's all. Take care, and I'll see y'all later.